Let's continue looking at Newton's work. Newton's laws involved views of space and time that we don't actually hold anymore, thanks to the work of Einstein. But back then, he conceived of time and space as being absolute. Space and time were linear, had no relation to each other or to anything external, and were immutable and true and unalterable over time. He used these phrases: absolute space without relation to anything external remains always similar and immovable. Absolute true and mathematical time of itself flows equably without relation to anything external. So space and time are independent of each other and absolute. He imagined various thought experiments to underlie the idea of absolute space and time. He also came up with his famous 3 laws of motion. He codified the idea that Galileo had had before him of inertia, that the state of rest and uniform motion are equivalent. This was Galilean relativity. He showed that the force on any object is given by the mass times the acceleration it produces. So the same force on a larger mass induces a smaller acceleration. And in his 3rd law, he decides that for each force there is an equal and opposite counterforce. Forces are always resisted. Most people forget that with the gravity that holds us to the Earth clearly exerts a force on us that gives us our weight, but we exert an equal and opposite force on the large planet below us. In his theory of universal gravitation, force due to mass, gravitas, is universal and follows the same law everywhere. And gravitational mass, the acceleration induced by gravity, is the same as inertial mass, which would be the resistance to motion in change of its motion. These are numerically the same, but it's an accident in Newton's theory. He doesn't have a deeper explanation for this. This would wait until Einstein to be fully explained. He conducted many experiments, however, to show the gravitational and inertial masses were the same things. He used, for example, the pendulum. If you think about it, it's not obvious that these are the same things. Inertial mass is the resistance to a change in motion. You can imagine a heavy stone on a smooth ice surface would resist if you pushed against it, but would eventually accelerate. That's transverse to the force of gravity, so it really doesn't have anything to do with gravity. It's about pushing sideways. Whereas gravitational mass of that same stone is the force that holds it onto the ice, and that reflects the way something would move under the gravity force. Kepler's 3 laws are a result of Newton's 3 laws in the law of gravity, so he fully explained Kepler's laws with new physics. He showed that orbital motions are conic sections, and so he was able to generalize the ellipses that Kepler had built into his explanation of planetary motions. And he realized, of course, that comets are moving in versions of the elliptical orbits, where they're highly eccentric, moving very far from the Sun and then coming into the inner solar system. He realized that the Earth's rotation causes it to be oblate, which is to say bulge at the equator. This is the cause of the tides. He also realized that the departure from a symmetric mass of a spherical object explains the precession of the equinoxes. And he did calculations to show that the orbit of the Moon actually varies as a result of it being in a 3-body system of the Earth, the Moon, and the suns. He needs an Epicurean universe to make his cosmology work. Infinite space and matter. And the theological implications of an infinite universe were not lost on Newton. Newton corresponded with the theologian Richard Bentley, and they discussed how God's perfection required an infinite universe, but also why there's a need for a creator to set everything in motion. In his later career, Newton moves down to London. He serves 2 short terms as Member of Parliament for Cambridge University, and he's appointed the Master of the Royal Mint. He becomes rich. This is a time in most scientists' life when they're going to kick back and relax. But he's still obsessed, and he's obsessed in different ways. One of the jobs of the Master of the Royal Mint, not usually followed because it was left to the police of the time, was to track down counterfeiters. He took this extremely seriously, and he actually developed some innovations like milled edges and other innovations of layered coins to try and combat counterfeiters. When they did catch counterfeiters, he was a bit of a ghoul. They would be sentenced to death, and punishment would be hanging at the gibbet in some central part of London, and he would visit all the executions and lead a cheering section of children from the local schools. So he was zealous in his tracking down of counterfeiters. He was elected president of the Royal Society, but he actually used that position to hound some of his rivals, for example, preventing Robert Hooke's work from ever being published during his own lifetime. He was appointed head of the Board of Longitude, and he continued, as we found out after his death, it wasn't obvious during his life, his theological studies. He died probably from complications of a gallstone in March of 1727, and he lived to a ripe old age. Newton was born apparently small enough to fit in a pint pot. He almost certainly died a virgin. He lived a very strange life in ways, but of course, when he was gone, he was widely celebrated for his contributions to science and civic life. Voltaire praised the British for making a hero of a heretic, and Newton is buried, as should be, in Westminster Abbey, where the greatest of the English have been buried over time. Newton railed against the idea of a clockwork universe, that is, a universe governed by laws, because he imagined it had to have an animating force, and so God must have put everything in motion in the first place. But what were these initial conditions? And what about free will in a mechanical clockwork universe? Newton worried that the solar system was unstable in the long run, that the planets might deviate in their orbits and perhaps leave their orbits entirely, and this would require God to intervene periodically to reset the clock. Here's Leibniz in a letter to Samuel Clarke. God Almighty wants to wind up his watch from time to time, otherwise it would cease to move. He had not, it seems, sufficient foresight to make it a perpetual motion. Newton railed against the magical thinking of pre-Enlightenment thinkers, but he invokes God where he is uncertain, and this is very much in the tradition of the more modern idea of intelligent design. We think of Newton as a great scientist, but in a way, he was a magician. This is a remarkable quote from John Maynard Keynes. Newton was not the first of the age of reason, he was the last of the magicians. Why did he say this? Because hundreds of years after Newton's death, boxes or trunks of unopened papers went on the market. John Maynard Keynes, of course, is a Nobel Prize-winning economist. In the 1930s, he was able to buy some of these trunks, papers that literally had not been seen for hundreds of years. He imagined and perhaps hoped there would be new scientific insights or works in them. Instead, what was inside the trunks were thousands of pages of dense biblical writing and interpretation. It was well known that Newton spent many years secretly practicing alchemy, or the idea of turning lead into gold by esoteric processes that were laid down in ancient Hermetic religious texts. Now, this is not an implausible thing. We think of alchemy as a pseudoscience, but lead and gold are both dull, malleable, dense metals. So it's not physically implausible to be able to turn one into the other, although we know that it cannot be done by chemical means. It's likely that his work in alchemy gave him lead poisoning, resulting in a period of time where he had literally toxic relations with other scientists, including his wars with Hooke and Leibniz. He never succeeded in his alchemy experiments because, of course, he didn't know that alchemy only occurs in stars. It's interesting how seamlessly Newton moved from mathematical and scientific work to things that we would think of as occult. In another area of his endeavor, he worked on prophecy. What Maynard Keynes had bought was a vast amount of dense biblical interpretation. In total, it far exceeded his whole scientific output. He held what were seen at the time as scandalous and even heretical views on the Trinity. This work was sealed and was bought at auction by Keynes and others. Newton was quite a sophisticate when it came to theology, but his ideas were bizarre, even for the time. He's laid down the groundwork for thinking about things that will come much later. He's laid down the groundwork for imagining space travel. We just had to get the technology to get it. He's laid down the groundwork for thinking of worlds in space and how they move and orbit and operate, and the idea of imagining life on them. And so this is the groundwork that leads to modern astronomy. and space travel, of course. And that's the end of this topic.